Hi, Robert. Thank you for joining the Opsani webinar series.
Thanks, Amir.
So, I've known quite a bit about you, and I have a lot of respect for your technical knowledge and technical expertise. I think it would be useful for the audience to know what your technical depth is and where you come from. So, could you introduce yourself?
Sure. So I'm currently providing a customer engagement role at Opsani, and what that is uh, supporting the optimization process for customers that have really unique and detailed optimization requirements for their applications. I come from an infrastructure automation background. So for the last 25, 30 years, I've been automating systems, whether it's applications, deployment and development systems, and the underlying infrastructure. And so with Opsani optimizing infrastructure components of applications, it just was a really good fit for me to come and help enable this process for our customers.
And I know that you're a Kubernetes expert. In fact, you run Kubernetes training classes. Isn't that correct?
Right. So as part of a different company, I do have a Kubernetes training set of courses, and we look at both the operations of a Kubernetes environment, but to me, what's more important is how do you leverage that tool set to actually get the best benefit of out of the environment. Again, looking at how can I optimize those environments, how can I actually just tie in the entire development process and get continuous delivery on Kubernetes environments. Of course, now we can do continuous optimization on them as well.
Excellent. Okay, so and which is why you're engaged with Opsani Vital. And as the world might know, Opsani Vital is our free product that you can try on Kubernetes environments. So the work that you and the team have done has been really instrumental in making it easy for Opsani Vital to get deployed quickly. So could you give us a few words about that?
Sure. I mean, the whole idea with Vital is that you can quickly come up to speed, especially in a Kubernetes environment where so many things are automatable, discoverable, and connectable. To basically have an application, as long as it's emitting metrics in some fashion or has a way of discovering those metrics. And actually, we're focused on Prometheus as our principal metrics capture engine, to be able to just say, here's my application. Let me download the code that connects me to the Opsani optimization service, because it is a service and as a service component to the optimization cycle. Launch the connector, which is the Servo component. This is a little, basically think of it as an agent or a plugin that plugs into your Kubernetes environment, discovers the metrics from within that environment, sends them to the optimizer, and then manage the optimization loop over time. And Vital helps make that super simple and very straightforward to accomplish.
And just to put a clarification, it's both Prometheus and Datadog.
Oh, right. Yeah. Well, I tend to focus on Prometheus, but you're absolutely right. It does Datadog as well.
So, as far as I know, you can go to opsani.com/vital and you fill out the form, and that's how you get your hands on the bits. Uh, and
Indeed.
and I believe you put it together a very nice tutorial.
Yeah. So one of the interesting things about the Opsani service is that in order to just help even our regular customers launch the service, we've created a component that pulls together the core resources that are needed to launch an application. And so we've built some tutorials which leverage an embedded application. It's just a little web server application to really simplify the entire process. So as a part of the Vital process, we can go through this little tutorial that I put together, and maybe this will help make it very clear how simple this process really is.
So without further ado, if you could start the video and show us what that great tutorial is. It's only 15 minutes in length, and afterwards we'll come back and see whether any questions have come in from the audience.
Great.
On today's tutorial, we're going to look at using Project Vital, which is effectively a quick start with Opsani, to rapidly deploy and optimize an application. Now, in our case, we're actually going to optimize an application that's included with a tutorial component, but we could apply this very rapidly to any application that you have, especially in the Kubernetes space. So first thing we have to do is sign up for Vital if we haven't done so already. So you can go ahead and add your name, your company, and your email. Great. Go ahead and ask for a free trial. We'll get an email after the context has been reviewed, and that will then lead us to logging into the Opsani console. We'll be told what account name to use. In this case, I'm going to use the Opsani account, which is a location that I have an account with Opsani already. And then I'll go ahead and say log in with Google. That will use my Google credentials. In this case, I have to pass those credentials in. Go ahead and sign in here. And that will get me to the main console. And what we're going to do is start with a new application, because with the new application, we have a couple of tutorial scripts. In this case, we have one specific one. We're going to go ahead and do a Vital Robert application. And then we're going to select a template. We're going to select the tutorial template. The blank template actually just has the core access credentials that we would need in order to configure and create a Servo environment. In this case, this includes a set of scripts and the descriptions needed to actually launch Servo in a Kubernetes environment. Now, the basic instructions that exist here we'll see again in just a moment. I'm going to go ahead and create the application because this does take a moment. And we're going to use a default namespace. In our case, we're going to create the Opsani tutorial namespace in our Kubernetes cluster. This gives us the option to tie into other clusters, maybe within our company, where we might not be able to just use the default namespace. So it just simplifies that process a little bit. The application is going to go ahead and do its creation, and as soon as we get our download link here, so download Servo artifacts, we can click on that link. And we can save the installer, so we'll just go ahead and say save that. And then I'll jump into a terminal session. Here I'm in a demo directory, and I'm going to just extract that file. Now, it ended up in the downloads directory for me. It'll end up wherever your downloads end up, and you can either use the file browser to extract this content, or here I'm going to do it on the command line. So we're going to do tar, which is the archive style that exists, we're going to use tar, which is the archive style that we produce the content in. And we're going to do xfz, which is extract file and compressed file, which is again the format. This lives in my ~downloads directory as servo install.tar.gz. This should work on basically any machine, Linux, Windows, or Mac. And once we've done that, we now have, doing an ls for directory listing, we have a servo_install directory. So we're going to go ahead and cd into servo_install and do an ls here, and we have a whole number of different files. The first thing that we want to do is just run our start script, and that's actually described here in the basic instructions. That's going to go and do a bunch of things, and it'll actually walk you through what it's going to do in just a second. Before we get there, we're waiting for the application to complete as well. So until the application is completed, we don't have access to our dashboard yet. And the dashboard is going to show us the optimization as the system is working through its different processes. So what we're going to want to do is go ahead and launch our application as the application continues to finish its creation process. And we're just going to have to do a /start.shell. Now again, this assumes that you have a Kubernetes cluster already created, and the system will then tell you exactly what it wants to do next. So we're going to update the Opsani optimizer, so that's going to tell it to use throughput as our performance variable. We have options to change how we would do that over time. We're going to create that namespace that we used as a part of our application request on the Opsani website. We're going to create the specific secret that the Servo needs. We're going to do that within the Kubernetes environment so that the Servo engine, which is a containerized application component that runs in our Kubernetes cluster, can talk back to the Opsani service. And as it goes through and does that, we're also going to create a service account and a role and role binding within that namespace. Basically, that allows the Servo application to talk to the local namespace and manipulate the application there. And then we're also going to go ahead and launch the Servo. Now, because this is a tutorial, we also have a little web application that also gets launched. So you can see the commands that are going to get run, create our namespace, create our authentication token for the Opsani service, and then we're going to go ahead and deploy the web application and our Servo as well. And I'm just going to hit yes here and let the system go ahead and do its little magic. Create the different resources that it needs. We also have a little annotation here at the end of the script that says if I want to see the current result of the servo running itself. So we can actually go look at the servo logs. I'm going to go ahead and copy this entire string, this entire kubectl. This is just a way of discovering the name of the Opsani servo so that it's simpler to actually just copy and paste. And now we see this is now the output of the servo talking to the backend service. It basically discovered the local environment, said, what does my system look like? And now it's gone off and has started to try to measure the application environment on a cyclic basis. We should be able to go back to our dashboard now and actually see the system operating. And we can see that there's some back and forth communication going on. The system finished an initial measurement, sent that measurement back, and now it's going into the adjustment phase, which is trying another set of values. Now, the actual scale of values, the scope of values that we can select, somewhat depends on what we have in terms of capacity and availability in our Kubernetes cluster, but we also have the ability to describe that in our configuration objects. But before we get too far into that, we can see here within the dashboard, we can see the state, so we don't actually have to look at the log file from the servo. We can get the general view of that state here. We see we're in an adjusting phase at the moment, and we'll go into a measurement phase next. We can also look at a similar version of the logs that we looked at on the command line here a moment ago from within the log viewer. This gives us a higher level view. We don't get quite the granularity of detail if we're looking at the individual logs, but it can give us an idea of the system's current running state and what it's finding. We can also look at the configuration. This is effectively what both the server-side configuration, the configuration that the user, i.e. you, has access to, and configuring the environment, and also some of the parameters that the servo code itself puts together. For example, the metrics that get collected. So here we're looking at error rate and latency and throughput. These particular metrics are being collected by the load generator. In this case, we're using Vegeta as the load generator, and generating an output result. We're also providing some control information. Our default duration on a test would be 120 seconds. And we are also defining the application adjustment range. Like I said, our guardrails for what we can adjust. And we're saying that CPU, we can have up to 1.5 cores of CPU and as low as 1/8 of a core. And we're going to step through that by 1/8 steps. So that's a total of 12 options, effectively, or 11 options for what we can actually test in terms of CPU ratios. And then we have a couple of replicas that we can test as well, either one replica or two replica across those 12. So right now, 24 possible combinations of things. So this is a small enough optimization space that potentially a human could go about doing and collecting all this information, but it gets us the starting point for this. Now we're going to start expanding on the number of options that we would test and validating more of the results. We'd actually probably also run for a longer duration to get a more efficient result in terms of our overall resources. And we're also defining within this configuration what we're looking for. In this case, we're saying we're going to look for performance, which is described as the throughput from our metric space. And we're going to compare that to cost. And since the two are sort of in quite a different bit of scope, we've actually raised the cost by an exponent of 1.5 to get our final results. And we can see those resources here in, for example, our optimization score, which gives us that result, our performance divided by our exponentially enhanced cost. In other words, we think cost is a little bit more important than the performance result. So we're looking for what is our lowest cost solution in this particular optimization trigger. We get a performance number. Now, performance in this particular case is being defined as throughputs, the number of requests per second that the load generator can generate. Our cost is derived from the cluster that we're deploying into. In this case, it's a statically derived. It makes an assumption of the size of the Kubernetes resources that we're working in. But in our case, we're really looking at relative cost. One resource, less CPU, is going to be more cost effective than more CPU in a Kubernetes environment in terms of what you can run across the entire cluster. The other thing we can see is, at least for the data set the data point that we have so far, we can see what our current performance was for that, what the cost was, what the ratio, basically the scoring function was, We can look at some of the latencies and throughputs. For example, we could say, well, maybe we want to change from latency or from throughput to a latency-based metric. So we could actually use the latency numbers here and use those as our performance metric. So lower latency, for example, would be better. So if we're hitting the system very hard and it doesn't have enough memory, potentially it might have to wait before it can make a response. So our latency might go up. And it's this kind of optimization that the system is really designed to do. Modifying the optimization is actually pretty straightforward too. We can do that within our environment here. The configuration for our optimization is all defined within our Servo document. And in following through the tutorial, if we look at the README real quick, in the tutorial, we actually go through and point at a couple of areas that you can look at modifying and enhancing our optimization. A simple one is to increase the number of optimization parameters. So here we have two: the number of replicas and the CPU interaction. If we look at our servo.yaml document, here you can see that same configuration that we were looking at in the UI a moment ago. And what we can do is we can edit this. I'm going to use the VI editor to edit my servo.yaml document. And I'm going to go and uncomment this memory callout. So here I have a couple of parameters, and we can just go ahead and remove the hash symbols before that. So now we're looking at CPU, memory, and replicas, and we're looking at optimizing those parameters. We're also defining the Vegeta resources and the Vegeta target, and you can see that all ties together. If you wanted to change the application that you were deploying, you would basically just need to say, as long as it was deployed in the same namespace, this is a name of the deployment and the container in the deployment that we're optimizing, that we're defining these parameters against. So obviously it's the deployment replicas, but then container, CPU, and memory limits is what we're really modifying in this particular demonstration. So you could apply that to another application so long as you're targeting the same namespace for those resources. And the simplest way to actually go about applying these new metrics is to go ahead and stop our environment. So we can do a stop.shell. And what this will do is it will actually go and remove all of the current running resources. And because there's no hard connection, there's just a secure key connection between the servo and what the servo is doing and the optimizer, you can always stop optimization just by turning off the servo, effectively what we're doing. Now, in our case, we're doing one step further. We're also turning off our application because we deployed both of them to the same namespace. But since we have our services updated, we can go ahead and do our start.shell script again. And we can say yes, and now it's going to take that updated servo document, which is our deployment document, and go ahead and run a new set of optimizations. Now you can see that the optimization service is back online, and it's gone back into its exploring, which is basically looking at the system state. We can go to look at our logs, and we can see that the servo is connected. And that we were waiting apparently for an adjustment to complete previously. So servo is connected, the system is now running, and we can see that actually it's started a second run. So our optimization has started, and we're now into the measurement phase. So if we go back into our dashboard, we can see adjustments happening, measurements are happening, and eventually we will have measurements pop up here. I'll just fast forward this part since it takes a few minutes to collect some data. Now we have both CPU and our memory parameter being defined, and we can see that as we go through and we increase, start with a baseline of performance and memory. As we increase our resources, our performance goes up, as does our cost. And so now we're looking for what is that optimal resource comparison between those two different domains. Once we have that optimum and the system has determined that it has found an optimal result, it'll actually call that out. But it currently still has a vision of what it thinks the optimum is, which in this case is the smallest amount of CPU and memory and the smallest amount of replicas is going to give us our best performance for cost optimized result. And and in this case, that's partially because of the way this particular application works, that we get that kind of a result. But we can let it go through and explore the different data points. And of course, where this gets more interesting is when we apply it to an actual application. But those are the basics of this environment. We're looking forward to having you try out Vital and, more importantly, apply this easily to your own application. Again, if you deploy Servo in the same namespace, just to show this again real quick, if we look at the servo.yaml document, basically we want to make sure that these parameters are appropriate for your particular application, specifically changing the component, the deployment name and the container name within the deployment are the two key pieces of data that we want. The rest of this should be the same. If you need to change the deployment name, you might also need to change the name for the target if you continue to use the Vegeta load generator. And the one other parameter that would need to change is the namespace is also defined here in this lower location. So just look for and swap out Opsani tutorial if you change the namespace, and swap out web if you change the application and or deployment name that's being targeted. Look forward to having you join us.
Well, Robert, thanks so much for that tutorial video. It shows how simple it is to get going with Opsani in a Kubernetes environment. I'm really grateful for your and your team's work on getting this thing rolling.
Great, yeah, and I think the nice thing about this is that once you have, especially given how Kubernetes interacts, once you have an initial application automated, it's very easy to take that exact same model and just apply it to another component, even in the same Kubernetes environment. It just really makes it very simple to continue to further your understanding from a simple initial startup to being able to automate your own application directly with that tool set.
All right, so while you were putting on video, a few questions came in, so I'm going to read some of them to you. The first one is, what do I need to have set up in order to launch Vital? I'm assuming that the user means in their Kubernetes environment.
Right, so as we saw in the tutorial, what we really need is a Kubernetes target environment that you have access to using the kubectl command line client. This is very commonly done. There are instructions on kubernetes.io. If you don't have something, the simplest way to get up and running is with a tool called Minikube, which will launch a local little Kubernetes environment. And most laptops even can support the kind of system we need. That's all covered in the tutorial, though, so it goes into more detail there. That's one thing. If you have your own application that you want to incorporate into this environment, then what you need to know is you need to know the target namespace and the deployment and the container that you want to optimize. Those are the key pieces of information. Everything else we can discover over time, but that will actually get the optimization started. And then as we continue to optimize, we can actually bring in a consulting engineer if necessary to help you fine-tune that optimization. But the initial pieces are access to a Kubernetes environment and a little bit of knowledge about the environment itself, your deployment and container within that deployment. That's the application. And the other thing that is actually important is access to the metrics service as well, because we want to capture those metrics as a part of that optimization process. In the tutorial, we actually have a load generator and a metrics engine that tie together and they provide the same service. But normally you would be using, as Amir, as you pointed out earlier, either Prometheus and or Datadog to capture the metrics from your application. So knowing the endpoint and the access credentials for that will be important as well.
Fantastic. Let's go to the second question, which is, what are the security implications of running Servo in my Kubernetes cluster?
This is really interesting because most people, when they're thinking about performance and optimization, they're thinking about an application or a service that gets really deep into the weeds of how their application works, potentially has access to the application data, and suddenly it opens up this huge number of potential security implications. In the Opsani environment, on the other hand, what we really see is a component that's really just talking to the edge of the application. We're looking at the application metadata. Yeah, we do want to know something about the application, its throughput, its latency, some of those sorts of parameters in the environment. But we also want to avoid actually looking at the application itself. So we're looking at metrics and we're looking at the underlying infrastructure, basically the ability to modify that infrastructure component, add resource or remove resource. And because that's all we're doing within the Servo, we're not usually touching any user data in any fashion. Actually, we're never touching user data in any fashion. So there's already one layer of security there. Now, we do have a SaaS component. There is the machine learning engine that actually does the optimization analysis and suggests new variants of the system to try. And that is collecting some information, but it's collecting those high level metrics, latency, throughput, data at that level. There are some environment variables type passing components that we also interact with, but these are also very much limited to modifying how the application runs, not the actual application data or application itself. So we're really touching very little of the system. And as much of that is abstracted into ones and zeros and truly basically enumerated lists of things where we don't even know what they mean. Instead of actually knowing a lot about the process. And it really sort of creates a very much a black box approach to the optimization where we don't need to know and don't want to know about the application. All we want to be able to do is get a result that lets us say, this was better or worse than the previous set of parameters that we tried. Try this new set of parameters. So the feedback loop is very little, very lightweight information. And honestly, all of the security audits that we've gone through so far, nobody has ever had any concern about the actual data that we need to pass out of the system because it's not critical to your application or your application value.
All right, and I assume that the transport between Servo and the backend is secure?
Of course, it's HTTPS TLS 1.3 or better, and of course it's properly encrypted and secured.
Thank you for that. All right, now there's a set of 4 questions that have come in, and I would group them as variations of the same one. So bear with me as I read through the 4, and you can answer them as one question. Number 1, what is the impact on my actual applications? Number 2, can I run this in production? Number 3, do I have to set up a parallel environment? And number 4, what effect does optimization have on my other services running in the same cluster? So they're all dancing around the same issue, which is, will Opsani somehow upset my production environment? And if so, what do I do about it?
Well, so there are a couple of different ways that we can actually run Opsani. We can run Opsani in a parallel environment. So if you really are concerned that somehow Opsani could impact your running production system, we can create a separate environment for that and work through those sorts of models. But our general optimization process, our sort of real long-running optimizations tend to work best in production environments. You're actually getting production load into the environment. We are siphoning off a portion of that production load, but we're siphoning it into a production equivalent resource. So we're taking a copy of your environment. So within the Kubernetes environment, this is known as a pod usually, right? We're taking that copy and implementing that. Sorry, go ahead.
A canary deployment in this case.
We're talking about a canary deployment, yeah. So many people know about canary from the normal DevOps world of discussion of a canary as a new resource that gets deployed. Often though, a canary is considered something that has new code in it. We're not changing the code. Our canary is what we call a production canary. So we're taking the exact same code that you're currently running in production, maybe at scale, maybe 3, 5, 10, 50, 70 pods, whatever the number of resources it is to meet your production scale, and we add one more resource. Or potentially we take one of your resources away and add a resource that's canary. And the only reason we're calling out that resource as separate is because we want to be able to make some modifications. We might want to restrict its memory. We might want to increase the amount of CPU that's allocated to that one particular resource to see if that's the thing that's going to make for a more efficient application. And with one resource out of N number, usually 10, 15, 20 additional resources, we are taking a portion of the traffic, but we can actually really minimize any impact of the changes that would occur with that particular application component. We are sitting behind a load balancer in all cases, and the load balancer actually becomes a part of that optimization cycle so that there's very little chance of any kind of disruption to your application or your cluster.
So basically it's designed to run in production, especially if you have a canary environment. Now that relates to the next question that come in is, can I use my own load generator, which suggests that there's a load gen environment, there's a canary environment. Can you expand on those and then talk about what sort of load gen you have?
Right. So if you're going into an environment where you want to do more of a performance optimization style operation, so this is our non-production approach, right? You can run a load generator. We have run a number of different load generators in this environment. What will happen is the servo needs to have a way of triggering that load generator for the application so that we have a known measurable life cycle for that load process. This works fairly well and that we're able to execute any basically binary based load generator or launch a container to run load generators or what have you. That is a little bit of a customization process on a case-by-case basis. But from the perspective of Vital, we by default provide the digital load generator as a way of generating general application load against your environment to run that initial optimization. Now, that's the load generator approach. The other approach is to use actual production load, and that's the canary approach that we sort of talked about in answer to your previous question. Running in production, often we're looking at production load as the generated load into the environment, and then we're going to optimize based on that and based over time as well.
Got it. And what load generator do you ship with the tutorial?
So the tutorial is using the Vegeta load generator, VEGETA. It's a Golang-based high-performance load generator that requires very little resource in order to actually generate a reasonable amount of load against an end system.
And of course, based on our previous conversations, you would recommend that people use live production loads because that's a lot more realistic, and you can
Yeah, and in general, what we find is that people that do sort of load generator style optimization, really they're using that more as a smoke test. They're validating that their application still runs and doesn't break in a known sort of scale of load. But more often than not, those load optimizations are not necessarily real world. It's hard to replicate real world user traffic against your application. So while that's a good way to get started and understand how your system scales and even use it as effectively a release component, run an optimization, make sure that you have the right scale to hit a certain load limit. What we find is that most people actually find it's more useful to run optimization continuously. And that really requires running in a production case, which for us is this canary mode of optimization. And that would then let you continuously optimize your application over time. In fact, you can actually take that optimization and apply it directly to the local running system so that it actually starts to act as effectively a scale manager as well. So we'll optimize the system and then make sure that it's always running optimally over long periods of time.
Very well. And that brings us to the last question that comes in, which is, where can I get my hands on this being Vital?
Oh, that's easy. Opsani.com/vital. All right, just sign up there and you'll get a response back once we're able to help you get up and running. But as you can see from the tutorial, that work is very, very easy. It's basically run a script and you're up and running.
So Opsani.com/vital. Well, there you have it. Robert, thank you so much for the time that you gave us and for the walk through the tutorial. It's really valuable. It shows how simple it is to optimize a Kubernetes workload with Opsani. And thanks everyone for joining this webinar, and please send us any questions at info@opsani.com. We look forward to hearing from you.